How do the seeded runs in Balatro work? If you've clicked on this video, you probably know what Balatro is, but just in case, here's a speedrun explanation. In Balatro, you start a run and then play cards from your deck, buy items, in order to score enough points to win. Each run is random, so you will see different items and draw cards in a different order every time. In Balatro, there are two kinds of run, unseeded and seeded. Unseeded is the default mode. You get in, everything is a random surprise, and you play normally. But if you and a friend both start a seeded run using the exact same seed, then you will see the same items in the shop, draw the same cards, and have the exact same RNG. This leads to a lot of fun shenanigans like competitions on the same seed, or seeds with particularly crazy RNG being shared online for all to play. Fans have even created tools you can use to view the contents of a seed. For example, on the seed Bold with the Ghost deck, we will get this list of items appearing in our anti-warden shop. But the question is, how does it work? And how has the developer Local Thunk coded this system where each seed is random compared to the others, the same seed always gives the same RNG, and it works perfectly even with saving, closing and reloading a run in progress? First, I think it's best to understand the rules that we are under for adding randomness to a game. If you want just the explanation of how the system in Balatro works, you can use the timestamps to skip ahead, but I think it's easy to understand the solution when you first understand the problem. Balatro is written in the programming language Lua, and Lua comes with functions for generating random numbers. Almost all other programming languages have their own versions of these functions, and they all work by first setting a seed and then doing some magic under the hood to generate random values. Two important things. Firstly, we're going to call this seed the math seed. In order to differentiate it from Balatro seed, we will call the run seed. And secondly, these kinds of functions work a bit differently depending on the language. Since you don't need to know how they work to understand Balatro's system, I'm not going to go into them. All you need to know is seed is set, value goes in, and a random number comes out. So why can't we just use these random functions and set the math seed to the run seed? Well, the answer is if we do that, then the RNG will desync pretty quickly. Under the hood, this randomness can be considered to be using the math seed to create a queue of random values. Each time our program calls to a random value, we take the first one in the queue. We can quickly see that under these conditions, timing is crucial to the randomness. In two seeded runs with the same seed, deck shuffle for example could be called twice. In one, it gets the first and third items from the queue, but in the other, we add in an extra visit to the shop before doing the second shuffle, and now we get the first and fourth items from the queue. This means different RNG. In fact, this doesn't just concern big things like shuffling and shops. All the UI effects, particles, hovering, sliding in, and so on could all be using random values, messing up our queue and ruining the whole point of having a seeded run. So how do we fix this? Well, we need to reset the math seed in order to control randomness. If we just set the same math seed before each deck shuffle, and then it will be shuffled the same way each time. Perhaps we can append a number onto the seed. And while we're at it, we could also add in a key in order to help make sure that our different random events don't mess each other up. For example, if we had the run seed Bold, we could do our deck shuffles by setting the math seed to Bold Shuffle 1, Bold Shuffle 2, and so on, with jokers being Bold Joker 1, Bold Joker 2, and you get the idea. And this system does work. Each run will now produce a queue for each key that's the same each time, but the problem is that by only varying math seed by incrementing a single character at the end each time, we won't produce proper random results. Such little and predictable variation will produce correlation in the random values, which we don't want. It could cause problems like getting similar shop contents again and again, or even blocking some jokers from ever appearing in certain seeds. We're not quite there, but this idea is good, and this is where Balatro's system comes in. The first thing to understand about Balatro's RNG system is the use of hashing. Hashing is where we pass in a number or string into a hash function, and it scrambles it without using randomness. Meaning if we pass in bold, it might scramble it to this weird looking 30-digit number, but it will always scramble it to this 30-digit number. So first of all, when a fresh run starts in Balatro, we need a seed. If the player gave one, then we use it. If they didn't, we use the time on the player's system clock and their mouse position to create an 8-digit string. Technically not random, for all intents and purposes it might as well be. And if we are playing the tutorial, the seed is set to tutorial. For an example, let's say we start a run with the seed bold. We then create an empty table called pseudo-random. Table in Lua is like a dictionary in Python. It has keys and values and works kind of like a textbook. We can look at the contents page, which shows us all the keys in the table, and we can then flip to a page for that key and read all the values written there. As well as holding onto our seed and this blank table, we also hash our seed and save this hash seed for later. Now later in the game, when a random value is needed, a call is made passing in a key which denotes what this random number is for, like idle or wheel. For this example, let's say we've used the wheel and we have called for a random number with the wheel key. On this key, we perform 3 steps. First, we check if the pseudo-random table has a wheel page. If it doesn't, then we make one by sticking together our seed and key, bold wheel, and then hashing this we get a scrambled number which we use as the initial value for the wheel page. Second, we take the current value on the wheel page of our pseudo-random table and we perform a different hash on it. This hash can be considered to be a sort of increment. Since the function produces the same output for the same input, you can keep passing a value into this function, getting another one out and then passing that one back in. The numbers produced will look wildly different and random. This is actually a sequence of numbers which is always the same if it has the same starting points. We then write the next value we get from this sequence to the wheel page, replacing the old one. And the final step is to take a copy of the value on the wheel page, half it, and add on our hashed seed that we saved at the start of the run. This step can be understood a bit like this. If the previous step gives us a sequence, then the jumps between each value are technically constant. By mixing in hash seed, we make it so that the jumps between the values in the sequence are of random length. It's still the same length each time, but it now depends on the seed at the start of the run, which ensures a more random output at the end. The function outputs this value, which is then set as the math seed, and the operation to get the random number or string is performed normally. This way, the system ensures that from each run seed, you can generate a random number on a per key basis, ensuring that deck shuffles, shops, and everything else are all independent of each other, and by using all these hash functions, we ensure that seeds really do feel random. A really good result of this system is that by saving and loading the seed and the pseudo-random table, we can ensure that RNG still works consistently even when the game is closed and a run is returned to later. This system is an implementation of a typical hash and a linear congruential generator, which you can go read more about if you want. You can also find proper implementations of these quite easily, but interestingly, Balatro uses its own version of these, although fundamentally it is the same thing. And there we have it. That's how Balatro's RNG and seed system actually works. If you enjoyed this video, please consider liking and subscribing. It lets me know you thought this video was good and it helps support the channel. Also, I'm developing my own game, Swope, a Minesweeper roguelike which is inspired by Balatro, which is kind of the whole reason I made this video. I wanted to find out how to do the seeded runs that work well, but also separated the behaviour of different events independently. And despite there being like 3 seed calculators online, I couldn't find a proper explanation of how the code actually worked, and it's very hard to find linear congruential generators when you're not sure what to Google. But anyway, thank you for watching, and I hope you have a great day.